Hello guys, I'm back with another video, another live stream for Recursion part 3. I don't know how many parts will be there, but that's all. One second, I'll share the link of this video. Omk, let's start. So, till now what we have learned is getting a strong hold on recursion. We learned about binary exponentiation and related problems, then two stack problems wherein we empty the stack and then fill it up according to a logic using recursion. So in both these problems we use recursion. Then after getting a strong hold, in today's stream we learned about generating all binary strings. We solved a little code problem of generating all the binary strings without consecutive ones, and then we did a problem for generating parentheses. So these two problems were of the type building the recursion tree from top to down, and the div nodes of our recursion tree were the actual answers. Okay, so we have a lot of problems left. Printing all subsequence and power set. Let's go to a new problem. Let's see what this is. Given an integer numbers array nums of unique elements, return all possible subsets, the power set. Okay, the solution set must not contain duplicate subsets. Return the solution in any order. So 1 to 3 is given. 1, 2, 3 and empty are the four things. 1 to 3 empty, and then 1 2 1 3 2 3 and 1 to 3. So here there are no duplicates. So let's try to imagine how we can do this. In order to get subsets, that is power sets, we have to, so now I already know that we have to use recursion for this. So let's say, what do we want to generate? All the subsets we are given 1 2 3. Let's start the, let's say we are pointing. Okay, we'll take an answer variable, which will be empty, then we'll add empty set in the start, or wait. So okay, yeah, I remember this. So I've solved this problem. This is about picking and not picking the elements. So where is the pen? Okay, so 1 2 3. So for every element I have multiple options, either to pick or to not pick. So if I don't pick any of this, not pick, then I'll get an empty set. I pick this, I don't pick this both, then I'll have one. Pick this 2 3. Okay, so this is about pick and non-pick. How do we do it in form of code is the question. Let's see if I have done this in C++. No. So without wasting time, in order to build a wrong logic, I will jump right on to the solution. Backtracking. the hell? Editorial, they have given a lot of different. This is a new approach, binary sorted lexicography. I don't know about this. Where is the one which I wanted? O n into 2 raised to n. What about this? It's the same. So define a backtrack function and backtrack first current takes the index of the first element to add and current combination. With the current combination algorithm backtracking. Given the definition, the problem can be interpreted as finding the power set from a sequence. So let us look over the length of the combination rather than candidate numbers and generate all the combinations for given length and help of backtracking technique. So all subset of length 0, all possible lengths of length n. So all subset of length 1, all subset of length 2. Backtracking is algorithm to find all solutions by exploring all potential candidates. For finding all solutions, so backtracking is finding all solutions, exploring all the potential candidate solution. If solution candidate turns out to be not a solution, then the backtracking algorithm discards it and makes some changes on the previous step. That is, it backtracks and then tries again. So take nums of 0 as the first element. Use next elements to complete the set. Use nums 1, subset is complete. Backtrack and then use nums 3, 1, 1, 3, 1. Okay. Take nums 1, 2 as the first element. Use the next element. Okay. We define backtrack function named backtrack first and current that takes the index of the first element to add and a current combination of arguments. So takes the index of the first element to add and current combination of arguments. If the current combination is done, we add the combination to the final output. Thus, if we iterate over the indexes I from first to length of n, length of the entire sequence n, add integer I to the current combination curve, add integer I to the current combination curve, proceed to add more integers, backtrack by removing. Okay. So this was the subsets. This is the outputs that we are going to return in the end. Output dot append current n is equal to length of nums, say 1 to 3, and then self dot backtrack 0. So this is where we start. First current, so current is empty in the start, and then first is the 0th element, nums is nums, and then we return self dot output here. So we have to update our self dot output based on whatever backtracking we do. So this is the backtrack function, first current. So what it will do? Okay, add the current subset to the output. Self dot output dot append current. So first, when a backtrack function is called, it will take the current and put it in the output, and then we'll generate the subsets starting from the current index. The current index was 0. For I in range, first, for I in range current index to the end. Okay. For I in range to the end. First I in range as 0. Current dot append nums of I. So we'll put first element into our list, and then we'll call the backtrack function based on that first element. Suppose it was 1 to 3, then current will be a list of 1, nums is same, and I plus 1 will be first element. So then we will find the elements on. So again, when this will call, the list of 1 will be put in the answer, and then we are doing current.pop. Okay, what does current.pop mean here? So from current we are removing 1, and then again the loop continues. And so what's exactly happening here is, what's happening here? Wait a minute, I got a mail. So we start a recursion here, and we run a loop for I ranging from first element 0 to n. So what we do is, whatever the I is, that we add to the answer. So current is equal to num of I. So now my answer becomes the first element or whatever element it is. Okay, and then after this we call a backtrack function. Okay, call the backtrack function with the I or the start. So start will be after this. So I plus 1 is the start, and we put current here and the nums and everything as it is, and then we pop it, nums.pop, num.pop, no sorry, current.pop. So what does this say, this flow? So this is the backtrack function. Now let's say it was 1 2 3. So first in output we already have this. After that, when 1 is added, 1 comes in output. After that it again comes down. Okay, and what happens for I in range first? So now the first is 1. So then we are thinking about hold on a second, hold on. So I popped it here, right? So self.backtrack will go on till when? Till it go on till n. So let me see the output of this function. I wanted to see what is the Python interpreter. format of nums. Where is it? Nums is a list. 1 2 3. Nums. Solution dot subset. Okay, so the output is this, then 1 when 1 is added, then 1 2, then 1 2 3. After all this is added, what happens is something gets popped. Not this. So after all this happens, something gets popped. What gets popped? 1 3. So 2 got popped, and then just 2 came. Let's ask ChatGPT, explain me the flow, because I know another technique. Okay, I understood this. I understood 1 2 3. 1 2 1 2 3. 2 2 1. वन थ्री कहाँ पे आया है? Where is 1 3? Remove 3. Current is equal to 2. Okay. So here's the logic. Now recurse. 1 already picked. 1 picked 2 2. 2 added. Output is equal to 1 1 2. After this, again once it happens, pick 3. And 1 to 3, added 1 to 3. Okay, after picking 3, return backward. Remove 3. Okay, we removed 3. So current becomes this. And again we remove 3. So is there a return statement anywhere? After the current subset, the upon. Okay, once this is completed, we pop it, and then it again goes into the loop and is current dot append. Remove 3, current 1 2. Remove 2, current 1. Back in backtrack 1 to next is equal to 2. Pick 3. Output is equal to 1 to remove 3, remove 1. Back to after 0. Pick 2. Recur. Pick 3, 2 3. Final iteration. Is equal to 2. Backtrack. Pick 3. Backtrack. Remove 3 and final. So here's the visual representation. So this was empty subset. It went into a tree. Went into a tree, went into a tree, and then while coming back, it comes back to this tree. 1 3 was added, 1 2 was added. So now 1 3 will be added. Why? Because 3 will be popped, and then iteration will be called for is equal to is equal to यार ओके आई इज इक्वल टू 3. ओके इसका 2 हो गया था. Then the next iteration for this will be I is equal to 3. Once this is done, so we comes to this tree. So this tree will complete 2, and then again it will go 2 3, and this. Let me know if you give a different approach for peak and not peak. So another intuitive and widely taught method for generating subsets, peak and not peak. So this is another method solution. Self output, self peak not peak. Self output is empty, self pick not pick. We start the recursion 0 and the nums. Wait a second. Okay, pick not pick. If I is equal to length of nums, so when I is equal to 3, the self dot nums dot append current. Append current का sub return. Not pick the current number. Self dot pick not pick. We are just doing I plus 1 current and nums, and picking current dot append. Current dot append I. Current dot append I. And then we again backtrack it. Why do I backtrack it? Is backtrack necessary? So try to imagine the tree in form of what ChatGPT showed me. So we add an element and then we call the function for backtracking. After calling the function for backtracking, we remove the element 2. Now we're left with 1. Then we again call the function for append. Then we remove 3. And then we remove 1. Oh, we remove 3. So once we remove 3, no, we remove 3, we remove 1, 2. Okay, so after recursion is called when we call the pop function, that is to backtrack to the original tree. So what is this? Empty. May differ in order but still correct. Pros: very intuitive, natural fit of a binary tree structure, easy to modify, problems like subset sum, combination accelerate. Let me know if you can convert. What's difference in complexities in this code and the code before it? Both versions of the code generate all subsets in the parser so that total number of operators 2 raised to n for input size, and there are subtle differences in time and space complexity depending on how they build and manage subsets. Let's compare your original code with backtracking with for loop. Uses a loop to explore each index from first to n, avoids revisiting earlier elements, not duplicate subsets. Yeah, I think this is better. Efficient pruning and natural subset growth. Pick or not pick, achieve index, other pick or not pick the element all the way through the both branches. So this is same. Often same. Total time is also same. So both approaches are of n into total number of subsets is 2 raised to n. Of entity append and pop. Append and pop. Because copying the current subset. Current takes off and time per subset space complexity. What? This is also same. So pick not pick is great for subset sum problems and more binary tree intuitive of 2n of n into 2 raised to n. Space complexity is call depth will go to n subset copy space will be n into 2 raised to n subset copy space. How will subset copy space be n into 2 raised to n? Is this something that I should remember? Anyways, looking back at this approach of pick and not pick, what's happening here? If I is equal to length of nums, so when I reaches the end, that is we are making a tree of pick and not pick, and so keep on increasing n I. So when I is n, whatever is in the output append current all the things in a tree. Then for here output dot append current all the things and then return, and then pick not pick. Alrighty, I'll do this by pick not pick approach. Subset sum. When I call subset sum, what do I need? I need an answer. Give the answer here. Then I call pick not pick function. Okay. I have self.pick not pick function. The first thing that will take in will be the index idx. And then we have the answer. Then we have nums. Answer nums. What else do we need? Let's say we need this much. I call self.pick not pick. And then I'll return answer. Okay, here I have to fill in the parameters, but let's see. I'll define this first. What the fish? Define pick not pick. First will be self, and then while picking or not picking, first thing that I'll do is the exit condition. Exit condition will be if length of if RDX is equal to length of nums, then whatever is in my answer, okay, one more thing here, that is my current string. Let's say string builder that we've used before too. Then answer dot append whatever the string builder gave, everything in string builder. And then I'll return. Then condition for pick, condition for not pick. Condition for pick will be index. So no, let's take first not pick. not weak and weak. So we're just using the index. String builder remains the same, and while we are picking, what we'll do is we want the current index to be picked. First let me call this function as it is. But before this, string builder dot append nums of rdx, and then I'll do string builder dot pop in order to backtrack, right? So this was my function for this. Now answer, what will be the index first? Will be 0. Answer is answer. Oh, string builder, what will my string builder be? String builder is a list that will be empty in the start, and then it will go on building. Then we want, what do we want? Answer nums. Nums is there here, answer is here, 0. This will go on, right? This is also increasing, so there is exit condition. Is anything missing? Okay, this is done. Again, go into solutions. So this was building a full tree, so this will be used a lot. What else? The better pruned tree for a solution that we saw was this. So let me try this once. So this is same the norms backtrack, so let pick not back. Let me define servlet backtrack. Backtrack. So comma index comma string builder, everything is same. Answer comma nums. So in order to prune the tree here, what they are doing is as soon as I get the answer, so here we had the exit condition, right? Here what they're doing is running a for loop which will end at some time in the future for everything, right? So no exit condition in this case, recursion with for loop. Okay, now what do I get? I'll do answer dot append sp string builder, everything is string builder. This is my first step, and then for I in range, the index that we have to index to length of nums, right? Index to length of nums, index to length of nums. So we considered a current element. Wait, where are we starting in this? Starting with 0, and there is nothing here. So we have considered the 0th element here. Answer dot append. Oh wait, string builder was nothing. So now for I in the range, 0th element, I will be 0. So I will first append 1 to the string builder. String builder append nums of I, and then I'll call this backtrack function. And when I call this backtrack function, this time the index that I give will be one more to move ahead, and string builder and answer and nums. Yeah, and then just to backtrack, I will do string builder dot pop. Okay, and then when we call this, instead of this, I'll call call self dot backtrack. Comment this out and run. Is there something missing? 1 1 2 1 2 3 1 3 1 3 3. Okay, so what went wrong here? Couldn't happen one. Starting from first, right? This I plus 1. Wait a minute. That means I haven't understood it properly. Why I? What are we backtracking here? Index. Did ChatGPT explain me this? Add the current subset to the output. Look through the rest of the elements. I think I need to use an example in order to understand this. So let's go in middle of the code. Backtrack 2. So here backtrack 2 starts. So everything for 1. Go back to the code. Okay. Let's start. So what happened? 1 is added. Then we call this with 1 the string builder. When the backtrack is called, we'll straight away put string builder in the answer, and then again it will come down. But when it comes to this, for the first time, then I will again become 1. Backtrack will again become the same, 1 plus 1. Okay, let me list down the backtrack calls that I see. Okay, so first backtrack call is this, right? And right now I care only about this thing, so empty string. Okay, then first backtrack will be nums of 0, I in range 0, idx is 0, right? 0 0. So this call will be 1. Let me list this call, and this will be 1. So whatever in string builder will come in the answer. Okay, next call. So when this will be called, what happens? String builder again will go here, and for I in range, this is a new call, right? For I in range idx, so idx here was 1, so the function that will be called is self.backtrack I plus 1, 1 plus 1 2, and the string builder is same 2, nums of I. Wait a minute, but इसमें तो nums of, what the fish? I is equal to, oh remember, I starting from index, that is I starting from 1. So for this anyhow it will be 1 plus 1 2. This is a very smart approach. I don't think I can think about such things in exam. And this will be 2, right? And then this will be 3. 1 2. Okay, so when this will be called, for I in the range 3 is the length of 3, length of nums 3. For in range 3, so 3. Oh, bruh. 1 second. Some basic Python. Okay. So this is where nothing happens in this loop, but the answer gets appended. So 1 1 2 3 is done. Now comes the point of relation. So the last call for this is done. Wait, which last call? Okay, so this thing called something but it didn't run, so it goes to the next line and does sp.pop. So same thing, string builder is now this sp.pop, and then I becomes what was I here? What the fuck was I here? I was 2 in last call, right? I was 2 in last call, so I is equal to 2, and 2 plus 1 3 and sp. Oh, sp dot append nums of 2, 0 1 2, nums of 2 is what? 3. Sp dot append nums of bruh. ऐड किया था, अभी 3 होगा, 3 की 3 लेंथ नहीं चलेगी. ओह यस, 3 की 3 लेंथ नहीं चलेगी. So this is done. Again one more function is called, and इसका 2 उड़ गया. Okay, and just because previous is it 3? Are you sure? Are you fucking sure? देवा, डोक्याची भाजी झाली. कुठे गेलो? Where is that cute little recursion tree? Okay, 1 2 1 2 3 ये हो गया. Then we backtracked, we removed 1 and 2 somehow. Okay, I removed the 2 and 3 somehow. Coming back to this, so this became 3 now. So जब ये 3 हो गया, then my range started running. जब ये 3 हो गया, then I answered it up and everything. आंसर में डाल दिया 1 2 3, and then for I in range 3 to 3. So when this function का recursion was called, so this function added the answer 1 to 3 in the answer, but this loop didn't run. So once this loop didn't run, the recursion that this was called that is this, वो हो गया, and then sb dot pop. So sb was this, so sb came this. SB was popped. Okay, now this recursion, SB was popped. This recursion will not be called yet. Just wait. Then it goes back. So where are we now? Right now, which recursion are we? Are we in this recursion? Let's say we are in this recursion because this is gone. So next call will be this, previous call will be this, 2 and 1 2. Okay. 2 and 1 2 will be called 2 and 1 2 का ये था ना, this call वो खत्म हो गया, पॉप कर दिया bro. 1 2 3 added, return and back, remove 3, remove 2, whatever guys. I am not trying to understand this anymore. Backtracking is hard. This is too smart way. And so what is this? Let's give this. This looks small. We did a bit manipulation, bit masking technique to generate all subset. Let's break this clever TikTok. What does this do? For I in range 2 square, or 2 raised to n and 2 raised to n plus 1, bit mask is equal to binary of I 3 colon. This is a compact way to generate all n length binary strings that represent inclusion exclusion of the element in subset. How it works is range 2 raised to n and 2 raised to n plus 1 generates numbers like from 3 like 1 2 raised to 3 is 8, so 8 to 2 raised to 4, that is 16, 8 to 16, so 1 0 0 0 8 to 16. So all three are masked, all three are open, everything is considered, and binary I converts the number into binary representation like 1 0 0. This is 8, right? So 3 slices of the 0b1. Okay, giving exactly n bits. So I'll have this bits, and then we have here this bits. So what will we do? Binary I 3 को आधा कोड है क्या भाई ये? अच्छा, आधा कोड था. Okay, understood. So perfectly implemented the bit masking. What's the code is? Generate all the subsets list. Okay, so this is bit masking. So for any number, if we start its range from 2 raised to n to 2 raised to n plus 1, the last 3 digits they will give. So the number was 3. So when we to 2 raised to 3, it's obviously more than that. That is 8. 8 has 4 bits in it, and we need 3 bits in the end. And 2 raised to n plus 1 has everything 1 1 1 1 1. Right? 15 is what? 8 plus 4, 8 9 10 11 12 13 14 15. Then okay, so 0 0 0 0 and 1 1 1 1. So we have all the combinations between this. We're looking to the values. These values have an bit mask. So this is the bit mask. That we do is we convert the binary of it, and then bin of I, and then So we have got the mask, convert the number to binary. Output dot append bit mask of j is equal to output dot append nums of j for j in range n. What is n? The length of number is given, which is number of j, number of I for j in range n. For j in range n, so j is 0, nums of 0, nums of 1. If bit mask of is equal to 1. Build the subset by checking each bit. Okay, ये example दिया अच्छे से. Binary of I, so this एक bit mask is 0 0 0 0 0 1 0 1 0. So created the bit mask from this. So not selecting any elements, selecting only third element, selecting. Oh, आज आशिक आजकल this is a clever technique. I think we've used this somewhere. N into 2 raised to n. You can scan n bits each for 2 raised to n numbers. You can scan n bits each for 2 raised to n numbers. Space complexity is n into 2 raised to n used to each subset of size up to n. So implement to avoid the slightly obscure trick, some prefer a more readable form for mask in range 2 raised to n. ये क्या किया भाई इसने? मास्क इंटेंट 2 raised to n. तो मास्क इन रेंज 2 raised to n. तो 8 तक गए, 0 0 था, नंबर 3 था, इसलिए लेफ्ट शिफ्ट किया शायद. ओह मास्क, व्हाई इज इट राइट शिफ्टिंग मैन? 1 था तो क्या होगा अगर लेफ्ट शिफ्ट किया था? 1 0 0 होगा. 0 0 1 करना है, मतलब क्या करना है? राइट शिफ्ट करना है. 2 रहेगा. 2 will be this. 2 will be 0 1 1. 2 will be 1 1 ना. तो wait bro. Subset mask right shifted by J. And 1 output record subset. Shifting avoids converting to binary string. Explain using tables. Okay. Table दे भाई. I don't want this. Good. Mask will go from 0 to 8. Our n was 3, right? N was 3. Binary mask 0 1 1 1. Then what we do is mask left shift by 0 and 1. Mask left shift by 0. अच्छा मतलब ये पोजीशन देख रहे 0 1 0 1 0 1. फिर mask left shift by 1 and 1. 0 0 1 1 0 0 1 1 by 2 and 1. 0 0 0 1 1 1. तो हमने क्या किया है? Everything is 0 0 0. तो included elements will be mask left shift at 0 and 1 को append कर रहे हैं. If mask left shift and j and 1, then nums of j for j in n. So j, nums of j subset is equal to, okay, nums of ये एक आएगा, दो आएगा, तीन आएगा, आउटपुट आएगा सबसे. ओके 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 ओके, ब्यूटीफुल. Let's do this 10 combinations. We took a lot of time in this problem, almost an hour. Okay, this is how we build a power set. I'll just remember pick and not pick. The other vector tracking was out of my thinking. Next up, what do we have? Next up, what do we have? Why is the dog wipe coding? Oh, 3 बज गए क्या? नहीं भाई, 4 बज गए. ये ऐसे तलब देते हैं भाई ये लोग. गेट पीसी गेम पास. ओ ये. Learn all patterns. Subsequence theory. Let us see. Class solution. Define better string. This is a hard problem. GFG GGG. Output GFG. The fuck? GFG has 6 distinct subsequence, whereas GGG has 3 distinct subsequence. But who asked? Given a pair of strings of equal length, your task is to find which two of the strings has more distinct subsequences. If both strings have the same number of distinct, then return S1. Otherwise, we have to return S2. Okay. So, let's think about what we have learned till now. One approach that I can think of is find everything for GFG, first string, find all the subsequences for second string, which one is greater, return it. So let's do that. I'll be using bit masking technique here because it was the shortest. Let's see if I remember bit masking that I learned. Okay, so first things first, for mask in range, S1 and S2 are equal lengths. Okay, for mask in range, length of S1, which will be raised to 2 raised to length of S1. So my mask will now be 1 2 3 0 1 2 0 1 2 7. Then my subsets generated for that particular mask range will be equal to, think about the problem once. So 0 0 0, then we have 0 0 1, then we have 0 1 1. How do we write 3? How do we write 4? 1 0 0. Huh? Something is missing. 2 was missing. 2 3 4. Okay, so for this, what I'll do is, abhi I will add the last thing. It will give me क्या देगा वो मुझे. For mask in range 2 raised to n, for j in range length of S1. So first j will be 0, then 1, then 2. Then first we are looking for last element. Okay, so if mask right shifted to 0, नहीं क्या बोल रहा हूँ मैं, mask right shifted to j, is it? What is mask right shifted to j? What is 1001 right shifted DJ? अच्छा ओके ओके बराबर है. And I'll do it and with 1 based on the bit manipulation lecture that I took. Mask if this is equal to 1, then I'll do what will I do? Wait, for every mask, for every one I'll generate one temp dot append thing dot append what, bro? Temp dot append append what is j here? J is 0, then j will be 1, so I will append I'll append last, पीछे से 0th, उसको कैसे लिखते हैं? n minus what is n? Fuck. N of s2 length of s1 minus length of s1 minus j length of s1 is minus j तो 0 है, length of s1 minus 0 क्या होगा? And I have to reduce it by 1 minus 1, but of whom? S1's ब्यूटीफुल. तो ऐसे करते करते मेरा टेम्प बन जाएगा. आफ्टर मेकिंग टेम्प, बिफोर दिस आई विल हैव आंसर इज इक्वल टू दिस, एंड देन आफ्टर माई टेम्प इज complete I'll do answer dot append whatever is in temp के सबजन क्या लिखा है बे? answer dot append empty string dot join temp. Wait a minute. Then what about distinct, man? Holy I'll make this as a function now. इसको क्या बोलते हैं हम? पावर सेट. define power set. Power sets first will be self. What else will power set was n? I'll say you go away. Answer 1 is equal to this, and call self dot power set with something. Answer 2 is equal to set. इसका भी पावर सेट बनाते हैं. self dot power set self dot power set something. What will it take? First of all, I'll find length of any one of them and give them as n. N is equal to length of s1 h1 answer 1. So first I'll pass answer 1 in this, then I'll pass n in this. I don't think there's anything else. Answer 2 in this, n in this. In this I'll pass string 1, in this I'll pass string 2. Okay, after passing both of them, if set of answer 1 is greater than set of answer 2 greater than equal to, I'll return s1 else return s2. So this is done here. Now I'll just modify this. What else would, so first was answer, go to second n तो है, and this was, let's say, S1 is the naming convention. For mask in range, this temp is equal to this temporary variable. I'll add temp dot append and then I'll do answer dot append. I think everything is good. And return. Self answer expected. Where bro? Good. सेट ही नहीं बनाया मैंने, वो बनाया. I think the time complexity will be the issue here because we are converting it to set. Output difference. Possibly your code does not work correctly for multiple test cases. First record this. How do I include this? Code's output. What happened in this? For mask in range, let's see. Whatever I've written, I'll first give it to ChatGPT. See what mistakes I made here. Trying to implement method to compare string 2 based on number of distinct substring parts and can. Here few issues in the code that is causing issues in code return. Has an early return. Oh, dumma. You can simply use this one object. Nice, bro. Dumbass. No, shouldn't have pressed submit. यार whatever. नहीं यार, ऐसे तो नहीं कॉपी कर सकता. 2 into S1 temp for chain range and length of S1. Oh, length of S. I don't think that's a problem here. If left shift of mask, right shift of mask J and 1, then temp dot append S1 of J. That's right. Better string. भाई क्या बोलूँ अभी मैं, इतना पागल इंसान हूँ ना. Only thing wrong was this. Okay, so this is going TLE. Now let's go to editorial. I knew this will go TLE. What have they done? Bro, what? What? डीपी कहाँ से आ गया भाई? भाई रिकर्जन कर रहा था मैं. बड़ा मोमेंट हो गया गाइस. इसको मैं बाद में देखूंगा. अच्छा स्ट्राइवर भैया ने बीच में ही डीपी क्यों डाल दिया इधर? ओके, दैट वाज द रीजन वी गॉट अ TLE. But remember, this is the technique, bit masking. So I think we only did just one problem today. This is very slow. Count all subsequences with some k. Where is DP? वाह वाह वाह, किया तो सब कुछ है. I don't remember anything. The question in thumbnail, if you see the thumbnail of this video, there is one question about the tower. Where is that question? Problem list. Bro, what's that question called, man? This is the question. Oh, Tower of an eye. This is that question. Tower of an eye. So this is the problem, that is this recursion to move disks between pegs according to specific rule. Return the problem in small step, ensuring all disks are correctly moved from source peg to destination. Disk. Move end disk from peg A to peg C. This is the question using the helper peg B. Move one disk at a time. A larger disk cannot be placed on a smaller disk. Main method initializes the current disk and is equally called Hanoi towers to solve the puzzle. Hanoi method. If there is only one disk, move directly from source peg. And recursion step, move n-1 disk from the source peg to the helper peg. Move the nth disk from the source peg to the destination peg, right? The last disk, as it is. Then move n-1 disk from helper peg. Move the n- disk from helper peg to what? C में डाला, B में डाला, ये B में डाला, ये C में डाला, ये में डाला, ये B का इस पे डाला. Okay. Java code. Let's see. If n is equal to 1, base. Okay, tower of an eye. Int n, source, helper, and destination. So helper. This is source. This is destination. And this is helper string. Okay. Int n. If n is equal to 1, base case. If there is just one disk, can directly move it from transfer disk from n to source to destination. Transfer disk 1 from source to destination. Yeah, return. Then tower of an eye. Step 1 is, what is step 1? Step 1, there are 3 steps that we have observed. n-1. So n-1. n-1. What the? n-1. -1. Numbers are numbered from 1, 2 and 3, right? And -1 is source destination helper. Transfer disk from N, transfer disk N. Why is it N -1? फ्रॉम सोर्स से हेल्पर पे डाला सबसे ऊपर वाला डिस्क. दैट इज द फर्स्ट स्टेप. देन हेल्पर से व्हाट इज स्टेप 2? ऊपर से हेल्पर में डाला. देन हेल्पर से डेस्टिनेशन में डाला. int is equal to number of disks, tower of n is equal to 3. Let's solve the problem. N is equal to 3. ABC. So ABC is name of this. ABC 3 ABC. N is not equal to 1, so nothing. Tower of n. Second disk from A source है, destination B है, helper C है. Transfer disk from N, transfer disk N. Get the third disk, transfer the third disk, first and third, from source A to helper to destination. Sorry, directly. Is it like that? From source to destination. Also, what is the use of this? So we are transferring from source to helper. Bro, what? चलो, what's up with this? And disk of different size. Move top and -1 disks from source to helper. Top and -1. Oh, from source to helper using destination as temporary is what they meant. And after that, transfer disk N from source to destination, and then क्या करना है? Move the nth largest disk from source to destination. अच्छा, this is to show that we have done that. उसके बाद what you do? Move n-1 disk from helper to destination using source as temporary. Okay, then again from helper to destination using source as temporary. Then वो क्या लिखेगा, transfer disk and from helper to source, source, and was one to disk from helper to DOS, this two from helper to second to first, right? Transfer disk 1 from A to C, ये पहला होगा. Transfer these two from helper to source, sorry, source to B. Bro, what? From A to C, first disk from A to C, these two from A to B, C, B, disk 1. पहली डिस्क डायरेक्ट लास्ट में डाल दी, सेकंड डिस्क दूसरे में डाल दी, हेल्पर में डाल दी, और फर्स्ट डिस्क है वो सी से वापस बी पे डाल दी. टक 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 टक, एंड देन डिस्क 3 जो नीचे थी सबसे वो 8 से 3 तक डाल दी. देन ट्रांसफ़र डिस्क 1 फ्रॉम बी टू है, ट्रांसफ़र डिस्क 1 फ्रॉम. So what is being followed here? The main logic here is, in order to place something in something, we are using something as a helper. So how do they switch? Looking here, सोर्स जो था, सोर्स टू हेल्पर, अरे सोर्स टू डेस्टिनेशन यूजिंग हेल्पर, सोर्स से डेस्टिनेशन पे डालना था पहले हेल्पर का मदद लेके. अभी बाद में क्या करना है, लेट मी थिंक. सोर्स से डेस्टिनेशन पे डाल रहे हैं हेल्पर का मदद लेके. अभी एवरीथिंग इज इन हेल्पर, तो अभी हेल्पर से डेस्टिनेशन डाल रहे सोर्स का मदद लेके. हेल्पर से सोर्स डाल रहे डेस्टिनेशन का मदद हेल्पर. इज इट? लेट्स लुक एट द डायग्राम. कहाँ गया डायग्राम? सोर्स से डेस्टिनेशन डाल रहे हेल्पर का मदद लेके. ओके, फॉर फर्स्ट. देन हेल्पर से, दैट इज राइट, हेल्पर से सोर्स में डाल रहे. सोर्स तो ये था, सोर्स ये था, ये डाला हेल्पर का मदद लेके. हेल्पर से सोर्स डाला डेस्टिनेशन का. हेल्पर से, वेट अ मिनट, फंक्शन का डिस्क्रिप्शन क्या है गधे? आई विल ट्राई टू अंडरस्टैंड फ्रॉम हियर. ओके, सोर्स टू डेस्टिनेशन यूजिंग हेल्पर, फिर सोर्स टू हेल्पर यूजिंग डेस्टिनेशन. इज दैट व्हाट इज डन? सोर्स टू डेस्टिनेशन, सोर्स, वेट क्या लिखा है? सोर्स टू हेल्पर यूजिंग डेस्टिनेशन, सोर्स source to helper, n-1 disks हम लोग सोर्स से हेल्पर में डाल रहे हैं यूजिंग, सोर्स से डेस्टिनेशन डाल रहे हैं यूजिंग हेल्पर, n-1 disks. हैंग हो गया भाई. नहीं समझा यार. Move n disks from source to destination using helper is the essence of the problem. So instead of moving all on their n disk, we start by going to the base of this. So 430. Okay. Instead of solving for n disk, we solve it for n minus 1 disks. So at the end, we reach at a point where only one disk is left. So when one disk is left, we just transfer the disk from source to destination. Okay, this is what this means. But when given that we are transferring n disks from, say, 3 disks from source to destination using helper, then in order to do it when we have sorted n minus 1 disks, there are two steps that need to be followed. First thing is, so let's say सब में एक एक है. So first we take it from source, we put it to helper using destination. Take it from source and we source से लेके helper में डाल दे using destination. source में थे 2, तो source से I put it in, I put one in destination, then only one was left. Okay, wait, small one big one source में, no, small one big one source में, I put the small in the first one to the last one, last में small है, then I move that smaller one, bigger one from A to B, then I put the smaller one on top of B. So after doing this, we have successfully transferred all the items, both items in A to B with the help of destination, and that is the first line. Source to helper using destination. Now we have to transfer from helper to destination using source. So now what we'll do is we will transfer the smaller in between, smaller is B to A, that is the helper, and then transfer bigger from A to C, and then we'll transfer smaller to C. Oh, easy. So what we are actually doing is shifting all the weights in the Hanoi tower from left to right, using the next one as the destination and the other one that is not used as a helper. Okay. So tower of Hanoi n minus 1 source destination. Okay, I got it. Transferring disks n from source to destination. Got it, guys. Let's look at the disk 1 from A to C, disk 2 from, wait a minute bro, which is, so first you're transferring disk 1 from A to C. Disk 1 is the smallest one from A to C, तो smallest C में डाला. Okay, फिर थोड़ा बड़ा जो 2 था वो B में डाला, then जो छोटा था उसी से P में डाला. So now we have n minus 1 from n minus 1 in helper, n minus 1 पक्का. Tower of Hanoi program. What is the rules of Tower of Hanoi? Are there equal number of sticks as the disks? No, the classic timeline always uses three rods. Source, destination, helper. This remains constant, no matter how many disks you have. Ah. Three rods are constant. That's why we have three rods are there. छोटा डिस्क ओके तो छोटा डिस्क डाल दिया वापस बी में तो अभी हमारे पास क्या है n-1 is quietly settled on this and my third disk is moved from A to C. Okay, now I'll ask them, tell me the output in case of 4 plates. Okay, let's see what's happening here. So move n-1 disk from source to helper using destination. Move the largest disk n source to destination. Move n-1 disk from helper. तो पहला डिस्क A to B, second डिस्क A to C. Second disk A to C. छोटा डिस्क बड़ा डिस्क तो फर्स्ट डिस्क from B to C. Bro, what? First disk from A to B. To C क्यों किया था इधर भी? How did this start with first disk from A to B? Transfer one disk from B to C. In this, how is okay. That's it for today, guys. Not many problems solved. So what is your primary coding language? Python by Python. आदित्य सूर्यवंशी. ये तो मैं बस टावर ऑफ हेनॉय देख रहा था. Anyways, the null pattern subsequence theories. तो first तो power set using DP का solution देखता हूँ एक बार. Not that I'm trying to study DP, but I just want to sleep peacefully. Power set using DP versus recursion versus DP and DC and SC and code. Recursion. Ah, fuck. Backtracking versus dynamic programming. Walk through what each method gives types was. Recursive approach, how it works step by step. हाँ ये सब पता है. Exclude and include, pick and not pick वाला approach बताया लोग ना. And then we are starting from 0 and empty string. Returning result if index is length of s. फिर जो भी बना है result में that I'll add to my part. जो भी path में that I'll add to my result. Path string builder. print power set ABC. Dynamic programming bottom up. How does it work? We start with an empty subset, build new subsets by adding each character to the all existing subsets. Time space complexity, same as recursion, storing also the spaces. No recursion stack, so it's iterative and memory safe. Okay. Power set DP. We are taking empty result, and for character as new subsets is equal to subset plus char for subset in result. तो रिजल्ट में पहले कुछ नहीं है, तो न्यू सबसेट विल बी सबसेट प्लस च, सबसेट प्लस ए फॉर सबसेट इन रिजल्ट. सबसेट प्लस च, तो ए हो गया. रिजल्ट डॉट एक्सटेंड न्यू सबसेट्स, तो रिजल्ट बढ़ गया. नाउ रिजल्ट इज ABC. अब इन A ओके टॉप डाउन बॉटम अप, often easier to trace, stack overflow risk no, subset combination permutation less flexible, output bit masking version. तो एक जो हार्ड प्रॉब्लम सॉल्व किया था हमने, हियर पावर सेट, कहाँ हो गया बबुआ? कहाँ से आ गया भाई? इसमें भी अगर bro what? Oh, beautiful. Okay. इसमें TL आ रहा है, कंट्रोल C, power set grows exponentially for a string and given a like a discuss use because say creates storing and comparing y sets is costly. Yeah, right. Okay, instead of generating all subsets, use a module to count the number of distinct subsets, which is what you are comparing. Use has set. Okay, and recursion only to generate unique subsequences. इसमें भी कर सकते हैं ना. नाइस ट्राई डमैस। क्या किया है भाई ने इधर? मतलब कहना क्या चाहते हो कि डीपी हमारी डीपी से बाढ़ रे। कौन टाइम सेट बना दिया एंड बाहर सेट था ना। करो क्या? चलो रिमेंबर पावर सेट। What is of index? Then I'll call the same line. Then I'll backtrack. this return. तो ये करने के बाद what I'll do is index here, 0th index, string builder will be empty, and then n will be the length of n will be n. What is this, bro? S will be s1 for now, and then I'll pass answer in this. Okay. After this, I get length of answer L1. Let's go to length of answer. Instead of making a new set, I will again do answer dot clear. Okay, so answer has nothing in it. Then I'll run the next set, the same thing using s2 and answer. I'll find L2. The answer if L1 is greater than L2. Who is missing, man? Line 12 solution.power set. What did I do here? Okay, here need to pass in answer in both of them. What is it? The same string builder. Index is 0, I increased it by 1. If index is n, then if index is n minus 1, yeah. If index is n minus 1, then I'll return na with change. Bro, what the? Bro, देखो इसे कहते हैं 4:30 बजे की गलतियाँ. सेट डॉट ऐड स्टूपिड डक. डू आई क्या ये होगा? इट्स नॉट 5:30, इट्स 5. भाई इसमें भी टाइम लिमिट एक्सीडेड हो रहा है. व्हाट एम आई डूइंग रॉन्ग हियर? फिक्स कोड टाइम कंप्लीट 2:n. लेट्स कॉपी पेस्ट दिस सॉल्यूशन. भाई कदे. Let's see if this works. I don't know what to say. चक्के नहीं चलना चाहिए यार. थैंक गॉड. टाइम लिमिट एक्सीडेड. गुड. TLE. Got it. You're still running time because the recursive power set generation 2:n. Infeasible string lengths greater than 20. We want to compare two strings and return the one with more distinct. Optimal approach avoid TLE is used with memoization to count distinct subsets. Distinct subsets. अरे बाप रे, इसको ये भी पता है. Okay. Brain can't process it anymore. हम करेंगे ये अगली बार. April Fools guys.